Our data sets are being eliminated intentionally. I'm a data journalist and I work with public data sets quite a bit. What I like to do is I like to break down charts. I thought it would be a useful exercise to break down some useful charts I saw. Using those charts, we're going to try to piece together the story and I'll fill in the gaps along the way. The main example I'm going to use today is weather forecasting. The United States and other countries have invested a lot of time and money into making national weather forecasting available and useful and better. And it pretty much is all those things. And they try to keep the data pretty readily available, or so they used to. Today's chart is from Our World in Data, which is one of my favorite sites. It shows how forecasting errors have decreased over time, and it's recorded in something called track miles. Track miles is how many miles off a forecast is from a hurricane's actual location. I think the multiple lines is a really good way to measure all of the timelines against each other in a similar fashion. I think this graph also does a good job with the annotation. Track mileage is a little hard to understand as a concept, but I think when you read out the words, you can understand that this specific error window in this specific decade had a track mileage of this. You don't necessarily have to be a meteorologist to understand what's being said in the graph. I took this graph as proof that forecasting has been increasing over time in a pretty good way. And a big part of that is for a few reasons. I know that machine learning has really came into the forefront. We also just have so much data. With atmosphere, the biggest thing is that it's a chaos problem. And a chaos problem just makes it so there are so many elements at play that it's really hard to get a definitive answer. However, the more data we have, the more we can narrow that gap. And that's kind of what you see in this chart. This chart breaks down how weather forecasting changes depending on how far out you're looking. So with the chart, it's a bar chart. We have a bar for every day, and the height of the bar corresponds to the accuracy of forecasting. Obviously, we have to use an average, so this is the daily temperature accuracy. While this bar chart is more like a snapshot, you can argue that this x-axis with all the days is kind of like a timeline, so it makes you think if a line chart would have been better. I personally prefer the bar chart. Overall, I think this chart really helped me clarify what the chaos problem is, which is the fact that there are just so many variables at play that it's hard to find an answer. Once it gets past 5 days, you really start to see diminishing returns. And by day 10, you're kind of guessing. Today's chart is from Our World in Data, and it looks at the accuracy of weather forecasts over time. Now you can see just top line, everything has improved over time. The chart looks a little complicated at first, and that's because there are a lot of elements at play. Similar to the last chart, it has a different line for every type of forecast. In this instance, we have the 3-day forecast, the 5-day forecast, the 7-day forecast, which is very similar to the buckets of time we talked about earlier. Now, weather forecasts are less accurate the further deep you're looking down. And you can see on the chart, they have percentage points of how each are doing in today's day. Now, you can see the 5-day forecast and the 3-day forecast make it past the 80% threshold, which is what most professionals consider the highly effective threshold. But when you look at the 7-day or the 10-day, they are just a little further down underneath the threshold. There are 2 separate lines for every type of forecast, one for the northern hemisphere and one for the southern hemisphere. What's really cool is that it started having a wide gap in the 80s and 90s, but it really coalesced in today's day, and now they're pretty much the same figure. This is because at first the northern hemisphere had all the rich countries, all the land, all the weather balloon stations. The southern hemisphere had just more colonized countries, and it's still mostly water. But luckily, the gap has closed. All in all, I think this chart does help us understand a little more about weather forecasting and is more evidence that weather forecasting has improved over time. And this is the 3rd chart that has done so. So at this point, what is the point I'm trying to convey? Well, the point is that this has been a public utility, information-wise, that has actually worked out for people. And this has been a current issue for the current Trump administration. They just have a bad habit of keeping up with these data sets. This is a chart that breaks down the budget proposals that Trump had for the 2027 year for the NOAA, and they're responsible for things like forecasting the weather and sending out disaster alerts. This chart breaks down their budgets from 2024 through 2026. What I like about this chart is the step-by-step nature of it, and you can see how it breaks down the NOAA into its subdivisions, and you can follow each of their paths. For the past few years, the budget has been relatively stable, even though Trump has tried to defund it quite a bit. Both in 2026 and 2027, Trump's proposals would cut the budget by 20% or so. And even in the 2027 proposal, you can see that out of the 7 subdivisions, Trump wants to cut funding for 5 of them. The other ones have modest increases. Now, estimates vary, but something like 3,000 to 6,000 datasets have been removed from agencies or stopped being maintained by agencies. Agencies like the CDC, the Census Bureau, agencies that we want to have as much information from them as possible. There are nonprofits and projects that are trying to save these datasets, but it's a shame because this is not how things should work. The government has the money and the infrastructure to keep and house all this information. You could say that the Trump administration is trying to silence science. This next chart is from the National Centers for Environmental Information. Basically, they have $1 billion disaster map, and that's exactly what you think it sounds like. They map out all the $1 billion disasters that have happened within the year. Now, this one is from 2025, but they have some going back to 2024, 2023, 2022. You get the point. You can see here that the United States kind of suffers from a lot of $1 billion disasters, from hurricanes to cyclones to drought. In 2024, there were $27 billion disasters. In 2025, there were 23, so a little better. Now, looking at this chart, it's interesting, but you really have to dig deep. Kind of mixed on their use of graphical elements. I do understand that they were trying to maintain geography. I think it does get the job done. I think the use of color and the use of different icons does help us distinguish between what disasters were happening where. You can see that quite a lot happened in the southeast, some happened in the middle of America. You can see the California wildfires on the left-hand side. The annotations they included were really helpful with the date and the name of the disaster. But I think this chart is a good example of the fact that this data is important to know. It's important to research. This can be helpful. And the Trump administration decided not to fund it. They just decided that they don't want to maintain it, and a nonprofit had to come in and rescue the effort, which has been happening in a few other cases. There's a data set called Silencing Science that looks at all the data sets that Trump has intentionally taken away or are just no longer maintained due to budget cuts. So at the end of the day, all of this is to say that the information that is stored by the government and maintained by the government is really precious to us, really precious to the journalists and the researchers and just the common people who care about this type of stuff. Luckily, there are still some people in Congress fighting back, and we still have nonprofits that are working to save this information. But data and information is a system that we need to support, or else we're just not going to know anything. That's it for me. Until next time.